So another way to solve a system of equations, in other words, find an x and a y value that works in both equations, is to use substitution, okay? So just like the word substitute, like if a substitute came in for me, they're kind of essentially taking the place of me for that day. It's kind of a similar idea, is you're going to be temporarily substituting part of an equation into the other equation to help you find x and y, okay? So how does substitution work? Well, it's actually going to work best when you have one of the equations having a variable by itself. In other words, and it could be either one. You could have x equals something or the y equals something. But as long as you have one of your equations with a variable by itself like that, you'll be able to use substitution to solve it, okay? So we're going to get right into the examples. To use substitution, you're going to start by looking at your equations, and you're going to see, do I have one of them looking like that? And so if you look at your first equation here, I have y equals something, okay? So I have y by itself. So that means you're going to be able to very easily use substitution to do that problem, okay? Well, how do you do that? Well, you're going to take whatever it's equal to, so like it's y equals all of this mess right there. You're going to take whatever it's equal to, and you're going to plug that in to the other equation for that variable. So it's y equals this. So in the other equation, you're going to find the y, and wherever you have a y, you actually are going to plug that in for it, okay? So in this equation, I'm going to copy it down real quick. I literally am going to erase my y, and I'm going to put parentheses wherever it was, and I'm going to plug that in. So my x plus 1 is going to take the place of that y, okay? So I put parentheses where the y was, and now I'm just going to take it and I'm going to plug it right in there, okay? So from there, notice that actually gets rid of one of my variables. And that's the whole goal, is to get rid of one of your variables so that you can solve it. And so now I just have to solve this equation. So the reason I put parentheses is just in case I had to multiply anything by this. And notice there's nothing outside of the parentheses that's being multiplied. And so really, if that's happening, then you can get rid of your parentheses, okay? So from there, you're going to combine like terms, because this 1 plus 1 will combine. My x will come down. 1 plus 1 is 2, so it'll be plus 2. And then that equals my 2x comes down, okay? Now, I've got x's on both sides, so I got to get those together. So I'm going to subtract my x so that it'll get over there with that x. X minus x is 0. My 2 comes down. 2x minus x, well, that's just x. And so my x is equal to 2. Okay, so that is actually the x value in the solution to the system. Now, we're missing something. Notice we're looking for an x and a y that works in both of them. So then how do I find my y? Well, all you have to do is take this and plug it back into one of your equations. So I usually just plug it back into the one that looks the easiest to deal with. And for me, that one looks the easiest right there. So I'm going to take my x, I'm going to take this equation, and where I have my x, I'm going to plug in my 2. Okay, and so when I plug that in, 2 plus 1 is 3. So the solution to this system is when x is 2 and y is 3. So if I plug that in and I check it, these should work in both equations, okay? So you could write your answer like that. You could write your answer as x equals 2 and y equals 3, okay? Or the other way that you could write it is, remember, this would be the coordinate that works in that equation, or both equations. So that would be the coordinate, like if you graphed those, that would be where it crosses each other, just like what we learned the other day, okay? So that is kind of how substitution works, is you take whatever it's equal to, You plug it in for that variable in the other equation, and then you solve, okay? So let's do another one. So if I was looking at these two, again, I'm gonna look to see if one of my equations has x by itself or y by itself. So that one's that's not happening in that one. That one, the x is by itself. So in this one, I'm gonna take whatever x is equal to, and I'm going to plug it in for x in the other equation. So my x in the other equation is right there. So I'm gonna be plugging this whole mess in for x right there, okay? So just like I did in the other one, I'm gonna copy down that equation. And whenever I get to x, I'm gonna actually put parentheses and I'm gonna plug this in. So when I've got to x, that's what goes in for x. And then I just simply copy the rest of my equation down, okay? The reason you do that again is so that you have one variable in the equation, okay? And then you simplify. So in this problem, it's a good thing I have the parentheses because that reminds me that 3 has to be distributed to everything that's beside it. So 3 times y is 3y, 3 times 2 is 6, and then my minus 4y comes down, and then I bring down the rest of it, okay? Then I keep simplifying. So these two are like terms, so I've got to take my 3y minus 4y. That would be a negative y, or negative 1y, and then my plus 6 comes down. From there, I have to keep solving, so I'm going to subtract my 6 to get it to the other side, to get it away from my y. My negative y comes down, negative 5 minus 6 ends up being negative 11. And then this is like a negative 1 times y, so I have to divide by negative 1 on both sides. So that goes away, and then negative 11 over negative 1 is 11, or positive 11. So that's the y. Again, you are missing part of this answer, so make sure you go back and find the other part. So we know what y is equal to. Now we have to take it and plug it back into one of these equations to find x. So again, choose the easier one. That one's way easier. So I'm going to take that one. I'm going to plug in my y. So it'd be y plus 2. And then I just simplify. So 11 plus 2 is 13. So again, you can write your answer as x equals 13 and y equals 11. Or if you wanted to write it as a coordinate, this would be the point where they would cross on the graph, okay? So we're gonna do 2 more examples, all right? And we have to solve those. So if I was trying to use substitution for these, then I'm gonna check for the same thing. So when I'm looking at these equations, I notice, let me make sure, yep. So making sure I didn't copy down the same equations as before. So I noticed that this one solved for y. So I'm going to take what it's equal to. I'm going to plug it in for y in the other equation. So I copy that other equation down. When I get to the y part, you put parentheses and plug in that whole mess that it's equal to. Make sure you take everything that's equal to. And then I copy down the rest of that equation, okay? Then simplify. So I got a 3 outside of this parentheses, so I'm going to distribute. So my 4x comes down. 3 times negative 2x is negative 6x. 3 times negative 1 is negative 3. My negative 3 comes down. Then I keep simplifying. 4x minus 2x is negative 2x. My minus 3 equals negative 3 comes down. I've got to add 3 to both sides. So those go away. I have negative 2x equals negative 3 plus 3 is 0. Divide by negative 2. X, well, 0 over anything is actually 0. So my x happens to be 0. It is okay. 0 is a number. So don't freak out if you get 0, okay? So then from there, you've got to take one of these equations and plug it in so that you can find y. All right, well, this one looks easier to me. So I'm going to take that equation. I'm going to plug in my 0 for x. So it'd be negative 2 times 0 minus 1. So negative 2 times 0 is 0. So that'll go away. And then my negative 1 comes down. So x equals 0 and y equals negative 1. Okay. So then the next one. This one, when I'm looking at it, we do not have this going on, okay? So if one of the variables is not by itself, what you're gonna have to do is get one of them where the variable is by itself, okay? So I'm gonna find whichever one would be easiest to do that with. So like when I'm looking at this, I could actually pretty easily get this y by itself if I just move the 6 to the other side. So that's what I'm gonna do. To get the 6 to the other side, you're gonna have to add 6 to both sides, okay? So when I do that, my y will be by itself, because those will go away. And then on this side, those two are not like terms, so you just take 5x plus 6 on this side, all right? Now, it's by itself, so just like in the other problems, it's y equals that. So in the other equation, you're gonna plug that in for y, okay? So I copy that equation down, and then when I get to the y part, I'm gonna write that in place of it, and make sure you put parentheses around it, okay? So that's what we get on this side, and then I have to copy the rest of it down, okay? Then I simplify. So I've got a -3 outside of this parentheses. That's why you have to put parentheses to remind you to distribute. So -3 times 5x is -15x. -3 times 6 is -18. And then my equals 60 comes down. Then from there, combine like terms. So 2x minus 15x is -13x. And then my minus 18 comes down. That comes down. And then I have to add my 18 to both sides. So then that goes away. My -13x comes down. And then 60 plus 18 is 78. And then from there, I have to divide by my -13. So I'm gonna have to just double check and make sure I don't do this part wrong. Okay, so that does equal -6. All right, so 78 divided by -13, we get -6. All right, so again, that's only part of your answer. So now you take that, you plug it back into one of your equations to find the other one. So this one looks a little easier. So I'm gonna take my y minus 6 equals the 5x, and instead of x, I'm going to plug in my -6. Okay, so y minus 6 comes down. 5 times -6 is -30. And then I have to add my 6 to both sides. So those go away. And then y would equal -24. So there's my x, there is my y. And then if you needed to check it, you would just plug it in and make sure that it works in both equations. So the last thing that we're going to talk about is the special cases that you can have when you're solving systems, okay? So you're going to notice that something kind of strange happens with these problems. And so we're going to talk about what to do when strange things happen, okay? So we're still solving by substitution. So remember, you want the x and the y to be by itself. And so when you're looking at your equation, or both of your equations, if one of the variables is not by itself, you've got to get it that way, okay? So when I'm looking at these equations, I don't have a variable by itself, okay? So that means I have to take one of them and get a variable by itself. Well, this one looks like it'd be a little easier. So I'm going to either get the a by itself or the b. And so for me, preference-wise, I would want to get the b by itself. So I'm going to move it to the other side. So I just subtract the b to both sides. And so when I do that, my a will be by itself. So it'd be a equals. And then I would have, I'm just going to bring that -b in front. And then that's a +5. So I'm going to put +5. All right. So once you have it by itself, it's a equals all of this. So just like in all the other problems, in the other equation, you're going to plug this in for a. Okay, so my a's right here. So I'm going to take this and I'm going to plug it in for the a. Okay, so I copy it down. And then when I get to the a part, I put parentheses and put all of that mess in there. Okay, so that's a. And then I copy down the rest of it. So it'd be +5b equals 25. Then I just simplify. I've got a 5 outside of these parentheses. So I have to distribute it. So it'd be 5 times -b, which is -5b. And then 5 times 5 is +25. and then I bring down the rest of my equation. Okay, then I've got to combine like terms. So my negative 5b and my 5b will combine, and notice negative 5 plus 5 is 0. So those actually go away. So this is where we start to get into the strange things happening. So my 25 comes down, and then that equals 25, all right? So when this happens, just like when we were like solving normal equations, when your variables go away and you're left with something like this, you're gonna have one of two answers. It's gonna be either no solution, or it's gonna have infinitely many solutions that will work, okay? So it's gonna be all or nothing, essentially, all right? So to figure out which one that is, you ask yourself a question. You ask yourself, is this true or false? Is that a true or false statement? Okay, if it's true, then that means there's going to be an infinite amount of solutions that will work for you to plug into A and B that will work in both equations. Okay, if it's false, then there is not going to be a solution that will work in either one of the, or both of the equations. There's not an A and a B that you can plug into both of them that would work in both of them. Okay, so is this true or false? Well, 25 is equal to 25, so it's true. So then that means, that is not your answer, but that means that your answer would be this system of equations would have infinitely many solutions to it. There's going to be an infinite amount of possibilities for A and B that you can plug in that will work in both of those equations. And the reason that is, if you think back to the graphs, is these actually happen to be the same line. Like if you graphed these, they are the same line on the graph, okay? So you could check that and see, all right? So that's one that would have infinitely many solutions, all right? So let's do this one. Substitution. You got to get one of your equations with a variable by itself. And so I actually have both of them with y equals. So you just pick one when that happens. So I'm just going to pick this one right here. You take what it's equal to. So it's y equals this. And so in the other equation, instead of y, I'm going to write that. So I'm plugging this 3x in for that y. Okay. So when I do that, I've got 3x right here. And I don't have to put parentheses because it's the only thing over there. And then I write down the rest of the equation. So equals 3x plus 2. All right, so then you have to solve. Your x's are on opposite sides of your equals mark. So you want to subtract your 3x to get them together. All right, 3x minus 3x, ooh, that's 0, equals, that goes away too. So you're left with the 2. Same kind of situation where your variables went away and you're left with something like this. Again, ask yourself, is this true or false? Because that's going to determine what the actual answer is. So 0 is definitely not the same thing as 2. So that's false. So again, this is not your answer. This is to help you know what the answer is. So if it's false, then that means that there is no solution that will work in that problem. In other words, there is not an x and a y that you can plug into both equations that will work in both. And the reason that is, so think back to the graphing that we did the other day, is because these two, if you graphed them, are actually parallel lines. And you can tell that because these are both in slope-intercept form and the slopes are the same. So parallel lines won't ever cross, so that means there won't be a solution to that system of equations.